Today we'll cover a lecture on types of fading in cellular system. So the learning outcome from this lecture is what is multipath delay spread, what is Doppler shift, what is coherence time, what is coherence bandwidth, and what are the different types of small scale. So first is multipath delay spread. So multipath delay spread arises because in between the transmitter and receiver there are multiple paths that the signal has to follow. In between these multiple paths, there are many concrete structures through which the signal reflects, which result into the multiple copies of the same transmitted signal. So there is a delay of these multiple copies to reach at the receiver, and this entire delay is known as delay spread. If the delay of the transmitted signal is greater than that of the symbol duration, then there is a chances that it will overlap into the symbol duration of the neighboring signal, which may result into the intersymbol interference. So multiple delay spread for urban area is kept to around 3 microseconds, and for hilly terrain it is kept to 10 microseconds. So let us see this figure where the y-axis is the received signal level and x-axis is the time delay. So the signal is going through multiple reflectors, first with the nearby reflector, then intermediate reflector, and then distant reflector, and this entire duration is known as delay. So next is Doppler shift. Doppler shift arises because there is a relative motion between the cell transmitter and the mobile user. So let us consider a mobile user is transmitting a signal at frequency fc, and it is not a stationary user, and it is moving either towards or away from the cell transmitter. In that case, if it is moving away or towards, in that case the frequency will fluctuate, and this fluctuation is because of the Doppler effect. So the spectrum will contain frequency fc plus fd or fc minus fd, where fd is the Doppler shift, and this Doppler shift depends on the speed of the mobile user and also on the speed of the reflecting object. So let us derive this Doppler shift. So let us consider a mobile user is at point A and moving at a constant velocity towards B and covering a path of D as shown in figure 2. So that if S is the source, uh, so which is considered to be very far from both A and B. So if S makes an angle theta with B, then the same angle theta with A. So the difference in the path length traveled by the wave from source S to mobile at point N A and B is delta L, which is equals to d cos theta. If you see this triangle, delta L is equals to d cos theta. D is equals to velocity into time. So it can be written as v delta t cos theta, where delta t is the time required for the mobile to travel from A to B. So the difference in the path length is related to the difference in the phase change. So if suppose mobile user is at point A at t equals to 0 and reaches at B at t equals to delta t, and if it makes an angle theta at A and it makes an angle theta plus delta phi at B, then the difference in the phase is delta phi, which is related to the path change, that is delta L, by a factor of wavelength lambda. So delta phi will be equals to 2 pi delta L by lambda. 2 pi is used to convert this into cycles per second. So 2 pi v delta t by lambda cos theta is the uh, phase change difference. So the Doppler shift can be obtained from this, because fd will be equals to 1 by 2 pi delta phi by delta t. So this can be written as v by lambda cos theta. So the Doppler shift will be maximum when theta will be equals to 0. That means when mobile is using in line with the direction of the received signal, and that is denoted by Fn. Next is coherence time. Coherence time is the statistical measure of time duration over which the channel impulse response is essentially time invariant. That means if the symbol period of the baseband signal is greater than that of the coherence time of the channel, in that case the channel will change during the transmission of the signal, hence distortion will occur. But if the symbol period of the baseband signal is less than that of the coherence time of the channel, in that case no distortion will be occurring at the receiver. Coherence time is inversely proportional to the Doppler spread, that is, it is a reciprocal of Doppler spread. Next is coherence bandwidth. It is the bandwidth of the channel which we can say that can be considered as flat, which passes all the transmitted signal with equal gain and linear phase. Coherence bandwidth is inverse of the delay spread, that means larger the delay spread, shorter the coherence bandwidth, and vice versa. So next is types of small scale fading in cellular system. Fading occurs due to two factors. First is multipath time delay spread and other one is due to Doppler spread. So fading due to multipath time delay spread is classified as flat fading and frequency selective fading, and fading due to Doppler spread is classified as fast fading and slow fading. Flat fading or non-selective fading. These are those kind of fadings in which the bandwidth of the channel is much greater than that of the transmitted signal bandwidth. So what happens that all the frequency uh, signal will be passed with constant gain and linear phase. So such fading will not affect the spectral characteristics of the transmitted signal. So only the strength of the received signal is affected due to this fading. So this fading is also known as narrowband fading, and this can be corrected just by increasing the transmitting power of the signal by around 20 to 30 dB. Next is frequency selective fading. In this type of fading, when the bandwidth of the transmitted signal is much greater than that of the bandwidth of the channel, so the fading will be different for different frequency signals. So the received signal is distorted in this fading. So this is also known as wideband fading, and it will be extremely difficult to compensate for the losses uh, in this fading. Next is fast fading, that is due to Doppler spread. In fast fading, if a mobile user is moving with a very fast pace, so there is a rapid fluctuation in the received signal strength of a mobile user in comparison to the change in the channel. That means the coherence time of the channel is smaller than the symbol period of the transmitted signal. This is also called the time selective fading. Next is slow fading. In this, if the mobile user is moving at a very slow pace, then there will be a very slow fluctuation in the received signal strength of the mobile user in comparison to the change in the channel. That means the coherence time of the channel is much larger than the symbol period of the transmitted signal. So this is called slow fading. That is for all. Thank you.